moving on. Let's do an example where we're given the three sides. So I'll draw another picture. I've got angle C, angle A, angle B, and I'm given that A equals 16, B equals 32, and C equals 19. And you'll notice we're missing all the angles. We have to find that. When you are looking to solve a triangle where you're given the three sides, always find the largest angle first. Again, that will be to minimize any chance of us causing an ambiguous case. And so we're going to find the largest angle first. In this problem, since side B is the longest side, that means angle B will be the largest angle. So we're looking for B first. And we'll be using the law of cosines here. Okay, so we have the cosine of B, because that's what we're looking for, angle B, and we plug in A, and we plug in C, and we subtract B squared over 2 times A times C, and we just plug that into the law of cosines. Again, this is a calculator problem. And so when I take the numerator and evaluate it, I get negative 407. When I take the denominator and multiply that out, I get 608. Plugging that in again into a calculator so that I have a decimal. Why? Because decimals are, in this case, are probably a more effective way to do the problem. We have the cosine of B equals that. So we don't really need to change it to a decimal. It's just good form. But again, we have cosine of an angle. So in order for us to find the measure of the angle, we have to invoke the inverse trig function, in this case, arc cosine. And that gives us B equals the arc cosine of negative 0.669, Plugging that into a calculator, again, remember it must be in degree mode. And when you plug it into the calculator, you get the angle B as an unrounded measure of 132.021383. I round it again to 3 decimal places. I make sure that I note that it's a degree measure, and there's angle B. Now in this problem, since in the last problem I switched over the law of sines, in this problem I kept it going with the law of cosines, just because I wanted to show it both ways. You could switch back over to the law of sines if you chose. I find actually the law of cosines is a little more accurate, so I kept it here. That's what I did. I still found the smaller angle. I did that next because A is the shorter side, although that's not mandatory in this case, especially if you're using the law of cosines. And I plug my values in. If I'm looking for cosine of A, then this becomes B squared plus C squared minus A squared over 2 times B times C. And again, very calculator driven. That gives me 1129 over 1216. And again, as a decimal, I have the cosine of A equals that decimal, which means in order to evaluate it, I have to use the inverse trig function. So angle A equals the arc cosine of the 0.928 number. And plugging that into my calculator in degree mode, I get angle A as a measure of 21.804917994 unrounded. I round it to 3 decimal places, and you'll notice when I do that, I get angle A is 21.805 degrees. And you'll notice one thing I don't do is when I have 2 angles, I don't then just add up the 2 and subtract it from 180, because that does introduce a margin of error. So I use the law of cosines again for the third angle. So now I look for cosine of angle C, and so I plug in A squared plus B squared minus C squared over 2 times A times B. And in a calculator, that gives me 919 over 1024, which is the decimal 0.897, ... C, that means equals the arc cosine of that number. And finally, in the calculator, that gives me a value of C of 26.173699979, and rounded, that is 26.174 degrees. And there's my 3 angles. Now, one way I can check to make sure that I'm at least reasonable is that I can add the measures of these 3 up, and they should add up to 180 degrees, which it does. In this case, exactly. Not always going to be exact, especially when you're rounding. In this case, it does work out to be exactly 180 degrees if you add those up. but it could easily have been with rounding errors that the last digit, or worse, if you're really off, the last digit might not add up to 0. It might not add up to 180.000. It could add up to 180.001 or 179.999. That's always a possibility. It probably doesn't mean you're wrong. It probably means it's just a rounding issue. When we round, that can happen. Okay, so, but in any case, it's a good check. It's a good way to verify that your result is reasonable and makes sense. Because if it doesn't add up to 180, if it's way off, then you know you made a mistake somewhere. Finally, a couple of problems, practice problems. This is one where I gave you two sides and the angle between them to use the law of cosines. And then if you want to switch the law of sines, you can, or you can continue using the law of cosines. And for the second example, I gave you all three sides. Again, you have to start with the law of cosines, make sure you pick the correct format, and then you can either switch over or continue to use the law of cosines. And I gave you the answers so you can check your answers. And there you go. That's the law of cosines in a very little bit detailed there, and with some examples to show you how it works. I hope that this is helpful, and good luck with the law of cosines.